Friends, today I am discussing the MCQs appeared in the Physiology Paper-I in the bracket RS4, that may be the code of the paper, of first MBBS examination of Rajiv Gandhi University of Health Sciences, Bengaluru, held on 9 February 2023. QP code is 1022. There are 10 multiple choice questions. Each of these questions are labeled with, because they are 21 and 22 questions in the serial order. Now, the question number 1, in the question paper, it is written as a 21-1 or 21I. Cephalic phase of gastric juice secretion is controlled mainly by A. Neural factors, B. Hormonal factors, C. Gastric distension, D. Presence of proteins in the stomach. Presence of proteins in the stomach means it is not a cephalic phase. Gastric distension is again the gastric part of the gastric phase. The hormonal factors, they are starting with either the gastric phase or the intestinal phase. So it is neural factors. You know that the number of inputs from the brain, even the psychological condition reflexes, and other hypothalamic influences, hypothalamic and limbic influences, they will stimulate the vagus in the medulla. That's the dorsal motor nucleus of the vagus in the medulla, and then bring about the actions. So therefore, the cephalic phase is activated predominantly by vagal input that originates from the brain region known as a dorsal vagal complex, which coordinates inputs from various higher centers. The vagal outflow to the stomach then releases a GRP, gastrin-releasing peptide, and acetylcholine, thereby initiates the secretory function. This is available in Genong's Review of Medical Physiology, 24th edition, 2012 is the year of publication, page 640. Only here, first time I'm mentioning about the details of the book. Subsequently, I will just say Genong. The next question is question number 2, 21-2 or 21II. Atrial systole coincides with the ventricular. Definitely it coincides with the ventricular diastole, but which phase of the ventricular diastole we have to examine? Is it the isometric contraction? Isometric contraction is not a ventricular diastole, it's a ventricular systole. A rapid ejection phase, that's again a systole. Last rapid filling phase, it is the filling phase that is in the ventricular diastole. At this time, the atria contracts and adds nearly 15 to 20% of the blood to the ventricles. So this acts as a primer pump or in this phase. So this is the answer is C, last rapid filling phase. It's not a ventricular relaxation. It's not isometric relaxation. So answer to this question is a last rapid filling phase. So this is being taken up. You have this reference in the many books. I have just given you for your reference a Guyton and Hall textbook of medical physiology, page 119, 14th edition, 2021. Moving on to question 3, that is 21-3. Descending limb of loop of Henle is permeable to all except A, water, B, sodium, C, urea, D, glucose. This question is rather a tricky one because the descending limb of loop of Henle is permeable to, as I read through this excerpt taken from Guyton and Hall textbook of medical physiology, page 350, the descending part of thin segment of loop of Henle is highly permeable to water. The first part, it is highly permeable to water and moderately permeable to most solutes. So the glucose is one of the solute. including urea and sodium, glucose, bicarbonate, or all the solutes in the present, it is permeable. Therefore, this question, because we have water, yes, what is permeable to water, highly permeable to water. Sodium, it is moderately permeable to sodium. It is moderately permeable to urea, and it is moderately permeable to glucose, because there is no, as you see here, it is also one of the solute. Therefore, there is no option which is available for the accept. Hence, this question do not have an answer. Moving on to the, and then it can be challenged. It can be challenged. The next, because in the answer, what I saw that glucose has been written. See, in normal health, what happens in the proximal tubule, all the glucose filtered is reabsorbed in the proximal tubule. But under the circumstances where it crosses the TMG, the transport maximum of glucose, the glucose appears in the subsequent portions of the nephron, especially the loop of Henle and the descending convoluted tubule and collecting duct. Under such circumstances, the glucose will permeate. So that is the point. So therefore, this question is do not have the answer. Next, moving on to question number 4, PCO2 of alveolar air in millimeters of mercury is, this question number 4 is 21.4. The PCO2 of alveolar air in millimeters of mercury is A 104, B 46, C 40, D 27. The question of 104 does not arise because that is limiting to the oxygen. 46 is a venous blood PCO2. Now the venous blood comes here in the alveolar air. Whatever has been exchanged, maybe it will equilibrate with the arterial blood that is equal to 40 millimeters. Maybe in the arterial blood it get mixed up and maybe it is a little higher than or greater than 40 millimeters of mercury. Anyway, so 40 and 27 is not the answer. So the answer to this question is 40. C 40 is the correct response. You can refer it to the guidance book in page 513. Moving on to question number 5. This is 21.5. Maximum velocity of conduction in the cardiac musculature is seen in. This musculature here is the conductive tissue. The conductive tissue in the cardiac musculature. Now, A, SA node, B, AV node, C, bundle of His, D, Purkinje fibers. Look in this table. This is table I borrowed it from Genong. Okay, Genong page 524. SA node have a conduction rate of 0.05 meters per second. It is slow. Atrial pathways is 1 meter per sec. AV node 0.05 meters per sec. Bundle of His is 1 meters per sec. Purkinje system 4 meters per sec. Ventricular muscle 1 meters per sec. Therefore, it is maximum here in the Purkinje system. Answer to this question is Purkinje fibers. So it is D, Purkinje fibers is the right response. Then moving on to the next question, question number 6. It is 22.1 or 22I. Edema can develop due to A, decrease in capillary hydrostatic pressure, B, increase in interstitial fluid hydrostatic pressure, C, decrease in capillary oncotic pressure, D, decrease in interstitial fluid colloid osmotic pressure. So this is a question concerning with the Starling forces. And if we know the Starling forces for the fluid movement, you can definitely hit these questions. Here I have mentioned the Starling forces. Starling forces are the Starling forces for fluid movement is equal to K, it is the permeability constant or the other factors, constant factors in major bracket. PC minus PI. PC is the capillary hydrostatic pressure. PI is the interstitial hydrostatic pressure. The difference between the capillary and the interstitial pressures. That's in at delta P. Then the minus the colloid osmotic pressure in the capillary and minus the colloid osmotic pressure in the interstitial fluid. It is this one determines the total fluid movement. Now, keeping this K as a constant because it's in the capillary, what I have just brought here, PC plus, that is the capillary hydrostatic pressure, plus the interstitial oncotic pressure, interstitial fluid oncotic pressure, or the favoring forces for the movement from the capillary side. Movement of fluid from capillary to the interstitium. Now, opposing forces are the interstitial fluid pressure, hydrostatic pressure, interstitial fluid pressure, because if the tissue is tough, then there is a large amount of pressure there, so that will oppose the movement. And also the colloid osmotic pressure in the capillaries, the blood is having the colloid osmotic pressure, or the plasma is having the colloid osmotic pressure, that will pull the water. So these are the opposing forces. So now, if you are looking at these answers, decrease in capillary hydrostatic pressure. A decrease in capillary hydrostatic pressure, if you can just see that these are favoring, usually in under equilibrium, favoring is equal to opposing, there is no edema. Okay, so now, so if this PC is less, the movement of fluid is from this direction, from the interstitium to the capillaries. It is getting into the capillary. Increase in interstitial fluid hydrostatic pressure. This is the increase in the interstitial fluid hydrostatic pressure. This pressure is increased. So then what happens? There's again a movement from the interstitium into the capillary or into the blood or into the circulation. Third, decrease in capillary oncotic pressure. So look at the capillary oncotic pressure. If this is decreased, this favors the movement from capillary to the interstitium. Thus, there is a edema. D, decrease in interstitial fluid colloid osmotic pressure. This is interstitial fluid colloid osmotic pressure. If this is decreased, so the movement is towards the capillary side into the circulation. Therefore, answer to this question is a decrease in capillary oncotic pressure. So that is true. And coming back to factor K here, factor K may be because it may be enhanced in case of inflammation or in case of the heat or any other factors, pore size, and etc. Can influence the factor K. That is a coefficient of permeability. So answer to question number 6, 22I is C, decrease in capillary oncotic pressure. Next, question number 7, it is 22.2. The plasma level at which a substance first appears in urine. Very easy question. A, renal threshold. B, renal clearance. C, tubular maximum. D, filtered load. Definitely, when it appears first in the urine, a plasma level, this appears, it is certainly threshold. It's not a clearance. Clearance is the amount of plasma cleared of its content, whatever the X content, substance X from the plasma. Tubular maximum is the capacity of the tubule to transport the substance across the membrane. Filtered load is the amount of the concentration of a substance times the filtration, the glomerular filtration rate. So that is filtered load. So therefore, answer to this question is a renal threshold. Renal threshold for glucose is plasma level at which glucose first appears in urine in more than the normal minute amounts. So it's Genong 682. You can refer to that. That's it. Moving on to question 8. Chief cells of gastric gland secrete. So there are chief cells and parietal cells in the gastric glands. The chief cells of the gastric gland secrete A. Hydrochloric acid, B. Mucus, C. Pepsinogen, D. Intrinsic factor. If you look back, the parietal or oxyntic cells which secrete hydrochloric acid and intrinsic factor. This hydrochloric acid and intrinsic factors are secreted from the parietal cells. The chief cells or the zymogen or peptic cells, they secrete pepsinogen and some amount of the gastric or the gastric lipase. These are the two things they secrete. It's mainly secrete pepsinogens. Answer to this question is pepsinogen. C, pepsinogen. That is the correct response. Now, question number 9, 22.4. Decompression sickness is due to A. Increased partial pressure of nitrogen in alveolar air. B. Bubbling of carbon dioxide in tissues. C. Decreased PO2 in atmospheric air. D. Nitrogen bubbles in body fluid. So it is the decompression sickness or the Caisson's disease is due to a person who is going for a deep sea diving and he remains in the deep sea for a long time, where nitrogen gets dissolved in the plasma or the body fluids, and this nitrogen then gets accumulated in the fatty tissue, and once he comes back to the sea level or the surface, then whatever the gases which are dissolved in the body fluids are released, and this release would be a sort of a decompression. This produces a decompression sickness, and this is answered usually nitrogen, because the nitrogen is in a major quantity. It's 80% of the total volume of the gases present in the air. So now the increased partial pressure of nitrogen in alveolar air, no, it's not that. Bubbling of carbon dioxide in tissues, no, it's not carbon dioxide, it's not oxygen, it's nitrogen. So I just read it for you from the guidance page 563. If a diver has beneath the sea long enough that large amounts of nitrogen have dissolved in the body, and the diver then suddenly comes back to the surface, significant quantities of nitrogen bubbles can develop in the body fluids that produces a bend, pain, and other symptoms. Besides that, because of the nitrogen, there is what is called a nitrogen narcosis. So there is a depression of the medullary centers. The question 10, 22.5. Warfarin acts as an anticoagulant by decreasing A. Calcium content of blood, B. Active form of vitamin K, C. Thrombin level, D. Platelet aggregation. If you are looking at this, the warfarin inhibits VKORC1, and by that warfarin decreases the available active form of vitamin K. So this means this is VKORC1 is necessary to activate the vitamin K, and this inhibits the VKORC1, and thus it decreases the active form of vitamin K. The answer to this question is B, active form of vitamin K. It's not the calcium content or thrombin level. Maybe thrombin level is the next step to occur because of the decrease in the active form of vitamin K, or it's not due to the platelet aggregation. So now these are the 10 questions in paper 1 of RGUHS University in 2023, and in this I found, or I have an issue with question number 21.3, which has no correct response. because I have already mentioned there is no answer available. As all the options are true, hence there is no exception. I just bring back that question 21.3. Descending limb of loop of Henle is permeable to all. It is permeable, maximally permeable to water. It is moderately permeable to sodium and urea and other solute, the glucose. Therefore, this question do not have the answer. One can take up this issue. Thank you all. Thank you all for your inputs. And please subscribe to the channel. Leave comments in the box. Mention any topic or questions to be discussed. Once again, I thank you.